we are going to go through our review for our test for Unit 1. The first one says list 5 multiples of the following number. Remember, when we say multiples, we see that the word multiply is kind of in there. So we want to use our number in a multiplication problem. And the answer for multiply. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And we can continue on and on. We often say that we find it by skip counting, because that gives us each answer to a multiplication problem. So 6, we could do 6 times 1 is 6. 6 times 2 is 12. And keep going. 18, 24, 30, 36. You don't have to start with 6. You could have started with 12. That's okay. And 13, even though it's prime, it still has multiples, because now it's not the answer, it's part of the problem. So 3 times 1 is 13. 3 times 2 is 26. 3 times 3 is 39. And then we can keep going onward and onward. And then 22, 44, 66, 88, 110. Okay. Number 2 says list the factors. Now, factors are the problem that gives this number as my answer. So I'm coming up with all the different ways to multiply to equal 9. I always start with 1 times 9, and you can write it as a multiplication problem. You can write it with the commas, biggest to smallest, that's up to you. And I can also do 3 times 3. Because it has 1, 2, 3, remember I only count the same number once, 3 factors, it is composite. Okay, for 12, I can do 1 times 12. I can do 2 times 6, and we could do 3 times 4. Because there's more than 2, it is composite. 17, the only way to get there is 1 times 17, and because there's only 2 factors, it is prime. And 36, I'm going to list this one like our rainbow. I can do 1 and 36, 2 and 18, because it's even, I knew 2 worked. 3 also works. 3 and 12. Try 4, yes, 4 works. It's 4 and 9. 5 does not work, because it does not end in 5 or 0. But 6 works, and it's 6 times 6. So I only need to write that number once. And because it has all those factors, it is composite. Number 3, a new prime number, which means we can't use 17. Okay? But you could write 2, 3, 5, 7, 11, 13, and it goes on and on and on. We did a notes sheet about prime and composite. You could look back at that. We colored all the composite numbers, so the ones that aren't colored, I believe, you could have listed. The important part is this definition. We know it is a prime number because it only has 2 factors. One and itself. That's the important part. That's how we know that it is prime. And same with composite. Okay? We can list a whole bunch of different numbers. You could have 4, 6, 8, 9, 10, 12, and keep going. Again, on that notes sheet, anyone that we colored, I think, were the composite numbers. The important part, again, is the definition. It has more than 2 factors. And then remember that 1 isn't prime or composite because it only has 1 factor. Okay, the second page Circle the equation. 8 times 7 equals 56. So I'm looking for, in my story, something that indicates the multiplication between 8 and 7. Letter A says 8 folders and 7 folders together. Well, together typically means add, so that one won't work. Okay? 56 crayons are 7 times, or 8 times the 7 crayons. Okay, so that one could be it, because I have 56 is 8 times 7. Here I have the difference between, that normally means subtraction, so that one's going to be out. And 8 erasers divided by, that won't work either. So I know that my answer is B. That's the one that talks about 8 times 7. Number 6. Circle the two equations, and I'm going to circle 2 so I don't forget. Tito picked 27 apples. That is 3 times as many as his little brother Marco picked. How many apples did Marco pick? Okay, so I need 3 times Marco to give me 27. Well, here I see the first one, 27 divided by Marco equals 3. That one might work, because that could be part of that fact family. Let's check the rest. 27 minus 3? No, I don't want to subtract anything. 27 times 3. Well, let me go back to my story. He picked 27, and 27 is, remember, that's our equal sign, so 3 times Marco. So I don't want to do 27 times 3. 27 equals something, so that one won't work. Letter D says 27 equals 3 times A, which is what they were using for Marco. That one is exactly like what we wanted. And we also know that A will work too then, because it is that fact family one. Number 7. Trevor is 15 years old. Trevor's uncle is 3 times older than Trevor. How old is Trevor's uncle? We need the equation and the answer. Remember that equation, we're using that variable. So I'm going to underline my important things. Trevor's 15 years old. His uncle is 3 times Trevor. So if I do 3 times Trevor, I'm going to say U for uncle. Okay? And then when I solve that, I get 45 years old. And you got the word years if you wanted, that's okay. Number 8. Rachel bought boots and a shirt. The boots cost 5 times as much as the shirt. The shirt cost $13. How much did the boots cost? Well, the boots cost 5 times the shirt, and the shirt was $13. So if I do 5 times the shirt, I'm going to get my boots. Okay? Then you need to pause and solve. And then when you are done, at $65 for the boots. Okay, remember that dollar sign is a label. And you could write it as 65 like that, or if you wanted, you could put the decimal point and the change. Then we have a ratio table. And I see one student brought in 12 folders, so it looks like to get from students to folders, I'm going to be multiplying by 12. So 2 times 12 is 24. 5 times 12 is 60. 12 times 9 is 108. And then 10 times 12 is 120. Okay. Number 10, our missing dimensions on our rectangles. I know 12 times 4 is 48, and 5 times 6 is 30. Number 11, we're filling in the facts. 5 times 9 is 45, 8 times 10 is 80, 8 times 9 is 72, 9 times 3 is 27. This one's tricky. Look, I have 5 and 40. That's my fact. So I know it's 50 times 8, because 5 times 8 is 40. 6 times 8 is 48. 7 times 6 is 42. 10 times 6 is 60. And 40 times 2 is 80. And number 12, there were 6 students in the green group. They each brought in 4 glue sticks to school. The class needs 9 times as much glue as the entire green group brought to last the whole year. How many glue sticks does the class need? I'm going to underline my important information. There are 6 students in the green group. They each brought 4 glue sticks, and that each kind of make me want to think about multiplying. The class needs 9 times as much glue as the entire green group. So I need to figure out my green group so I can figure out my whole class. Okay. Again, for my green group, I had 6 students and they each brought 4 glue sticks. So I'm going to do 6 times 4 is 24 glue sticks. Then the class needs 9 times as much glue as that. So then I need to take that times 9 to get my whole class. Okay? So I'm going to put this as my equation now. My first thing I did was 6 times 4, and then I did that times 9 to equal, I'm going to say C for my whole class. And you can solve it however you want. I'm going to just the traditional way. And I got 216 glue sticks. That's a lot of glue sticks. Okay. Number 13. Claire saw 4 columns of crayons in a box of 32 crayons. How many crayons are in each column? So we've got 4 columns and 32 is my total. So 4 times something equaled my 32. Instead of that blank, I'm going to put in that C for crayons. To make it a division equation, I just rearrange my fact family. 32 divided by 4 equaled some number of crayons. And I know that fact. If I didn't know my fact, I would be using a strategy to figure it out. And I got 8 crayons. Number 14, Michael bought a basketball and a frisbee. The basketball cost $54. The frisbee cost $6. How many times more did the frisbee than the basketball cost? Okay, so if the frisbee was 6, I need 6 times something to get to that 54. Again, I'm going to say T for how many times more. To write it as a division problem, I would say 54 divided by 6 equals something. Okay. And then I use whatever strategy I need to figure that out, and I end up with the basketball costs 9 times more. Number 15. The Hufflepuff table group has 6 students, and each student brought 4 dry erase markers. The Gryffindor table has 6 students, and each student brought 2 dry erase markers. After they collected the markers, Mrs. Rowling divided them evenly among the students of these 2 tables. How many markers did each student get? Well, let's break it down. Let's start with the Hufflepuff table. Okay, they had 6 students, and they each brought in 4. And I see that each again, which means multiply. So we should do 6 times 4. Okay. The Gryffindor table had 6 students, and they each brought in 2. So the Gryffindor table had 6 students, and they each brought in 2. Okay. After that, they collected the markers. So I need to take my amounts and collect them together, and collected typically means add. Okay. Then Mrs. Rowling divided them evenly among the students. So I have 36 and I'm dividing them evenly among the students. Well, I have to go back and look. I had 6 students here and 6 students here. So I'm dividing it by the 12 total students. And I end up with 3. So I know that they each get 3 markers. Now let's go back and figure out what equation I did. Did I add all of those numbers? No, so it's not that one. Okay. The next one says I did 6 times 4. I did that. Okay. Then it says I did 6 times 2. I did that. Then I added them together. I did that. Oh, but then I also divided. This is missing a step, so that's not the right one. Okay. And the only difference between these two is that division and that multiplication symbol. Well, I can see here I divided, so my answer is going to be C, because I did not multiply that 12 back in. Okay. So take a moment and go back through the ones, if you didn't know any of them, and check your work. And then make sure we finish that study packet so we are ready for our test.